So this is the first problem of today's contest, and in this problem we are given that there are two n positive integers written on a whiteboard, and being bored, you decided to play a one-player game with the numbers on the whiteboard. So you start with a score 0, and then you will increase your score by performing the following move exactly n times. That is, choose two integers x and y that are written on the whiteboard, add minimum of xy to your score, and erase both x and y from the whiteboard. So now we will perform this move exactly n times, and after we have performed these operations n times, there would be no integers left on the whiteboard. So we have to find the maximum value that can be achieved if we optimally perform these n moves. So we are given two n values. Let's say n was 4. So we are given 2 times n, that is 8 values like this, right? And out of this, we'll perform 4 operations, and each time we'll choose two int values. Both of them will be removed from the whiteboard, and the minimum of these will be added to a score. So by intuition only, see, let's say the array is sorted. So each value will be paired with each value will be paired once, right? So if this is the minimum value, this will always be in your, this will always come in your final answer. Like this will always get added. So this should be paired with something, like whatever you pair this value with, it won't come, right? Because this is the minimum value. So technically whatever you're pairing this value with will get ignored. So this is the next bigger value. You should pair these two. Why? Because then only you are ensuring that this value won't be included in your final answer. So if you pair it with any other value, then that value will be getting ignored, and you want to ignore the least value possible. Why? Because you have to maximize your answer. So by same logic, after sorting, these two are paired, these two are paired, these two are paired, and these two are paired. And these, if you sum up these values, because the minimum of these is this only, if you sum up these values, you will get your final answer. Is anyone having any doubt in this? Yes, no, anything. Okay, okay. What about others? Is there any doubt? Okay, so let me show you the implementation. Just give me a second. I'll have to copy the implementation. Where is it? Okay, this is it. So this is the implementation. In this, I have first taken n as input, then I have taken the array of size 2n, because the values that are given to us are 2n. Then I'm sorting it, and I'm adding all the values starting from first index, but I'm leaving, I'm adding alternate values, not alternate, but I'm leaving one and then adding. So finally I'm printing this. Is anyone having any doubt in the implementation? This is pretty simple, so I don't think anyone would be having any doubt. So can I move to the next problem, or? Okay, so now let's go to the next problem. So this is the next problem. In this problem, we are given that we are given a positive integer n, and we need to find a permutation p of length n such that there do not exist two distinct indices I and j such that both are between 1 and n minus, like less than n, 1 and less than n, and I is not equal to j, and such that pi divides pj and pi plus 1 divides pj plus 1. So let me explain this here. See, let's say this is a permutation. So we need to find a permutation such that I and j must be between 1 and less than n. So between 1 and less than n, and pi divides pj. This like is 0, and these things shouldn't be true. So by the way, this is just one way of showing I and j. Your j can be here and your I can be here also. So then your I plus 1 would be this thing and your j plus 1 would be this thing, right? So this shouldn't also happen that I divides j and I plus 1 divides j plus 1. And this should also not happen that I divides j and I plus 1 divides j plus 1. So both of these shouldn't happen. Now this is a like straightforward constructive problem or like observation. You don't have any kind of algorithm involved in this. There is just like how can you build this kind of permutation. So like how I solved this, I just tried different ways of writing the C. First of all, you cannot write something like 1, 2, 3, 4. What is the flaw with this? The basic flaw with this is 1 divides everything and 2 divides even numbers. 1, 2, and this won't work, right? Yes, no, because 1 divides everything. 2 will eventually divide a even number, right? So this thing is flawed. Now let's try something. So let's try this in reverse, like 1 can be left here, and then let's say n was equals to 9, n was equals to 6. So we can write something like 6, 5, 4, 3, 2. So now, is there like still any issue? So you can see like, okay, 2 divides 4, but 3 doesn't divide 5, or 2 divides 6, but 3 doesn't divide 1. So this way this works, but this is like if you try this kind of sequence for a bigger value like n equals to 9, then you'll see the issue that you'll. So what happens here is 2 divides 8 and 3 divides 9. So this will eventually like this, if you for any bigger value of than 9, this will always be the case. Like 2 will divide 14, 3 will divide 15. So this can also not, like we cannot have something like 2, 3 and like numbers after this. So now let's try some other like what like what else, like what other pattern can you write? Like 1 will eventually come here, okay, but what about other numbers? See, what is happening? If a number is dividing another number and it's a permutation, if it's a permutation, then all the numbers are between 1 and n, right? So I'm trying to plot my permutation numbers. So this is my pi and this is my I. So if I have something like this, I is this, j is this, and my I plus 1 is this, and my j plus 1 is this, then I can say that okay, I divides j and I plus 1 divides j plus 1, or something like I is I plus 1, I is here, j is here, I plus 1 is here, j plus 1 is here. So I, j, I plus 1 and j plus 1. Why? Because I plus I plus 1, j plus 1. So I is dividing j, so j, the value at j must be more than I because it's a permutation. Every value is unique, right? And j plus 1 must be more than I plus 1, right? This is also true, like you can also write this when I is more than j. This is the case when I is less than j. So basically this is the kind of thing, right? That your value a of I should be less than a of I plus 1, a of j. And your value at a of I plus 1 must be less than a of j plus 1. Then only these will divide, right? Then only aj is divisible by ai, and then only aj plus 1 is divisible by a of I plus 1, right? Yes, no? Okay, so now try to come up with an approach for which even though if ai is less than ai plus 1, this kind of thing is not true. Can you come up with the approach?
Two-pointer approach.
How?
Move I pointer to the right, left, and j pointer to the left.
Okay, so yes, if I try to draw something like say 1, then very big value, then something small. If you have something like this, like alternating values, so this is 1, then n, then 2, then n minus 1, then 3, then n minus 2, or like this. So then if you look at in forward direction, no, like this number will not divide any other number. Why? Because this is maximum. This number may divide other numbers, but let's say this number is, if it's dividing this number, then also like 2 can divide. If n is 9, 2 will divide 8, but 8 cannot divide anything after, like 8 cannot divide anything after that, because again by the same rule, because 8 is more than every other number after this point. Same thing, like 2 can divide this thing, n minus 2. For n equals to 10, we will have 8 here, so 2 can divide this thing, but this number won't be able to divide anything. And in the backward direction, if you look, let's say 2 divides n. It's possible when n is equals to 8 or n is equals to 10, then 2 will divide this thing, but this number doesn't have anything to divide because it is maximum. 3 can divide n minus 1, but can n minus 1 divide anything before it? So here you can look at this, like how to prove this, that no, it won't, because you have to look at just one place before, right? So one place before is a value which is less. Same thing here. You have to look if this number divides n minus 1, then you'll have to look one back, two, three positions back. So 3 positions back, you'll have a number which is less than n minus 1. Is it making sense? Yes, no? So that's why you can have this alternating kind of thing, that first you print 1, then you print n, then you print 2, then you print n minus 1. So 1, 2, 3 will increase, and n minus 1, n minus 2, this kind of thing, all the way up till you have printed all the numbers. Is it clear? Yes, no? Okay, okay, it's understood. So let me show you the implementation. So this is the implementation. In this, I have first taken n as input, then I have inserted all my values in set. You don't have to actually, like, you can also do this without using set. Like just do this using 2 pointers and an array. Like insert all the values from 1 to n in an array, or you don't need even an array, just 2 pointers. But what I have done, I have keeping things simple, just insert the values inside. If I is odd, print the smallest value in set. If I is even, print the biggest value in your set. And while you are printing these values, keep erasing them, because eventually you should print a permutation, not like the permutation shouldn't have repeated values. So finally, after we have printed this permutation, that is alternating first smallest, then biggest, then smallest, and smallest by smallest I mean not overall smallest, the smallest among the remaining elements, because again it's a permutation. And we can print this is just next line. Is that clear? We are just alternating this because then we won't find such I j and I plus 1 j plus 1 such that I divides j and I plus 1 divides j plus 1. Simply as that. And this doesn't mean I is j, by the way. I can be more than j also, both of these. So let's go to the next problem.
Can you explain this graph?
Yes, which?
The last graph.
This thing, right?
Yeah, yeah.
Yes, this is nothing but these are the values pi, and this is your I. Like this is your first place, your second place, this is your third place. So let's see what's going to happen if you have values like this. So this is your from 1, 2, 3 all the way up till n. This is your p of 1, so I'm saying it's 1. Then it's n. Then the next thing is 2. Then the next thing is n minus 1. So basically this I'm trying to print your p array p is 1, n minus, not n, 2, n minus 1, 3, n minus 2, 4, like this. So you have to just print, like plot these values. This is the first index, second index, third index value, fourth index, fifth, sixth, seventh. If you plot these values, you'll get something like this, right? Right? Something like this, right?
Yes.
So yes, using this only, you can see that you won't get that condition in your, like in this graph, that you get this thing. So using this, you can see that if I divides j, then I plus 1 won't divide j plus 1. Is it clear now? Yes, no?
I understood the yes how you're saying, but how does this guarantee that uh, I that the given the ask thing like
Like
if
we
I
can say,
divide
if
yeah
I divides anything, if I divides, let's say this thing, j, then the value at I plus 1 would be more than the value at j plus 1. So I plus 1 cannot divide j plus 1. And this is true for, if you look at backwards also. If I divides j, this is I, this is j, then I plus 1 cannot divide j plus 1. Why? Because the value at this place is more than this place. Is it clear now?
yeah okay okay.
Clear to everyone? Okay, so let's go to the, like I have also shown the implementation. The implementation is straightforward, just keep the maximum and minimum values alternating. So let's go to the next problem. So in the next problem, we have Stack has an array A of length n, and he also has an empty set S. Now we need to note that this S is not a multiset. So he will do the following 3-step operations exactly n times. Select an index I such that I is between 1 and the length of array A. Insert AI plus I into Si is nothing but the position or the index of this value, and we need to insert ai plus I in set S and delete ai from A. Now all the elements that occurred after this point or after this value, their indices will get decreased by 1. Finally, after all the operations, array A will be empty and we need to construct another array B, which is nothing but like from this S, which is set, we need to sort all the values in decreasing order and formally print B. Like then let's say like once these values in set are sorted in decreasing order, this is array B, and out of all such array Bs, we need to print the lexicographically maximum array. So let me first of all explain what is being asked. See, let's take an example for this. So let's take this example, 6, 4, 8, and 2, 1. So 2, 1, see, what we can do, either we can first add a value to this. So this is first index, second index. So we added 2 to this, we'll get 3, and this will be removed. Then we can add, this is at first index, we can add 1 to this, we'll get again 3, and this will be removed, but I won't insert 3 again in my set, right? So this way we only get 3. But let's see some other way. This is at first index, this is at our second index. So first let's add this thing. So then we'll get 3, this will be removed, and the index of this will now become 1. So now add this to this and you'll get 2. So this is your lexicographically maximum. Like 3, this is more like everybody knows what's like, how do you compare two arrays lexicographically, right? Basically, like dictionary order, right? So that is lexicographically. So for 6, 4, 8, what we can do, this is at first index, second index, third index. So first add these two, you'll get 11 and remove this. Then what can we do? Add these two and you'll get 7. And then for 4, you have the index as 1, right? Because this is also removed. So you'll get 5. So 11, 7, and 5. Is that clear? Yes, no? No, just wait for a second. 11, C. But is there any better way to do this? See, there is also one more better way. So these were the initial index. So first add these two, you'll get, here we had 8. You'll get 11. This is removed. Then add 4 to. So after adding 4 to, you'll get 6, and then add these two, 7. So after you sort this in non-decreasing order, because you'll have, this is your set. This is your set. You have to sort this in non-decreasing order. So you get 11, 7, and 6. And this is lexicographically more than this thing. So that's why this is the answer for this test case. Like first remove this, then remove this, then remove this. Is it clear? Yes, no? Or is there any other doubt in this?
How we got 1175?
You got, like, we can get 1175 if what is it? Like if we first do this, then we do this. So after this point, there is only one element left, and the index of this will be 1, right? So 4 plus 1 is 5. So first this, second this, and third operation this. Then you'll get 1175. Is it clear? And
Mm-hmm, okay.
if you do first operation this, second operation this thing, and then third operation then this, you'll get 1176. Why 1176? Because these two added will give you 11. These two added, this is at second position because this is not removed currently. So 4 plus 2 will give you 6, and 6 plus 1 will eventually give you 7. And then you have to sort it in non-decreasing order. So 1176. Is it clear to everyone? Okay. So now tell me one thing. Let's say this is your array A, here you will add 1. What is the maximum value that you can add here? 1. What is the maximum value that you can add here? 2. What is the maximum value that you can add here? 3, 4, 5, 6, 7, 8, all the way up till n. So these are the maximum values that you can add here. Suppose, let's say this is the maximum value that you can get at this point. Tell me one thing. This is the maximum value out of like after adding these values, the maximum value that you're getting in this array is at this point.
It will be the largest element in the array, right? It should be the,
Why?
because that element plus index 6 is giving you the highest value among all.
Let's say this is your array. So this is not the maximum element, right? But still 1, 2, 3, 4, 5, 6, 7, 8. If you add these values, you'll get 11 here. Let's say this is 6. So we'll get 11 here, 3, 4, 5, 6, 12, 8, 9. Eventually, you're getting the maximum value here, but this was not the maximum element. So that kind of assumption is wrong, that this value will be maximum initially. Is it clear?
Yeah.
Okay. So now let's say it is occurring at some point. So first of all, you should start here. You should start at start. You should have this value only because you want lexicographically maximum. Like eventually your array will be sorted, but the thing is, this would be at the first place, right? Yes, no. Okay, and after this point, you don't have to repeat this value because if you repeat this value, what will happen?
First place, I didn't get what first place.
Like if there are two arrays and one is lexicographically more, let's say this is array A, this is array B, this one is lexicographically more. So this value needs to be bigger, right? Bigger than this value, right?
Yeah, yeah.
So the first, if you want to make lexicographically maximum array, lexicographically biggest array, then you will try to have the maximum value at the first place, right? This is your array B, final array B. So in this, you need to have the maximum value at the first place, right? And even though like finally you will sort in non-decreasing order, you will sort in non-decreasing order, but in your set you need to have the big like one biggest value, right? And that value will come in the first place of array B. Why? Because you're sorting in non-decreasing order. You'll sort your set in non-decreasing order. So what is this biggest value that can be in array B or in your set? It is this thing, right? So after sorting in non-decreasing order, this will come in the first place. Is it clear now? Yes, no.
There are some queries. Please look at the chat.
Yes, yes, yes. But like, who asked me this thing regarding first? Like, as he left the call. Okay, anyway. So now let's say there were two, like here there was 6 and here there was a 5. So now the value here is also the same. But the point is, once you have taken this value, you get 12 here. All these values get decreased by 1. So instead of getting 12 here, you're getting 11. Right? So 11 can come here. But how to decide this? Like what value will come afterward? So what you can do, like initially like just add these values to your array and sort them in non-decreasing order, because then see, choosing value, like if you choose this value, all the further values will get decreased by 1 after adding. So you have like a upper hand on deciding whether you want to get 6 added here, or you want 5 added here, or 4, or 3, or 2, or 1. Why? Because if you take one element before selecting this, you will get 5 added. If you take no element before this and you take this element before, all of these elements, you'll get 6 added. If you would have taken one element before, then you would add 5, so on, right? So you have this kind of flexibility. So what we can do, we can start with the maximum element in this new array, that is after adding these indices to the values. And what we can do, we can, like, let's say at start the maximum is something like int max or like infinity, and we'll iterate through our array A, which is sorted in non-decreasing order, sorted in non-decreasing order. And then what we can do, and this is not just array A, this is AI plus I array, AI plus I array. So what we can do, if the maximum value that we have up till now is more than the value that I'm currently incurring, let's say it's E, then simply this is the best value, like just print E. Otherwise, if maximum value is less than or equals to E, then can someone tell me what should I do? First of all, maximum value won't be less than or equals to, it will be equals to only. But let's say maximum value is less than or equals to E, then what should I do? That
What
means, like, here also I could get E and here also I can get E. Like in above case, I can get 12 here also and 12 here also. So what should I do?
take the 12 of
Like once I can get 12, okay, but 12 I have already, I already have a value. Like let's say up till val I have printed everything, or like something I have, the last number that was printed was val. If val is more than E, then print E. Why? Like I have like the lexicographically, the I have to print the maximum array, right? And lastly I could get 12. Now after, when I'm iterating through this array, I got 7. So I'm saying that you should print 7 here. But if the value was less than or equals to E, then you should print value minus 1, because you can always, like I said, you can always decrease 1 or 2. So then print val minus 1, because this is simply like you have printed everything up till val. Don't print this E, because then it is just going in your multi-set, but it's not actually contributing. Like it is going in your set, not multi-set. It is going in your set, but it's not contributing. Yes, yes, yes.
Can you please repeat? Not understanding
Which part?
this part only from E onwards.
Okay, okay. See, val is nothing but the last value that you included in your set. So if your value is more than the current value in when you're iterating over your array, then what you should do, you should include this E only and update your value, because now this is the last value that you are including in your set. But in the case when your last included value in your set is less than the value that you are like that you get upon iterating, then include val minus 1. Why val minus 1? Because you have something like you have included 12, then 11, then 9, then 8, and now you incurred again 9. So if you again insert 9 in your set, it won't contribute. So instead insert 7. That is val was this thing, val minus 1. And you can always do this. Why? Because like I said, just first like remove 2 elements before the 7. Like eventually the order doesn't matter, right? Eventually you can get this thing after sorting in non-decreasing order. Maybe you get something like 12, 1, 2, 7, 8, 9. But after sorting you get 12, 9, 8, 7, 2, 1. So that's why you can always get this kind of order, but before this 7, you should remove 2 values, because otherwise there is a 9 here. Okay, is it clear? Yes, no?
So let the 9 be there, right? Why should we do -2?
Yes, because if there are 2 9s, then your array, like this is your set. So then your array will become like your set is this thing, your 9 will be only included once. So then your array B will become 12, 9, 8, 2, 1. But if I have a 7 here, then my array is 12, 9, 8, 7, 2, 1. So tell me which is lexicographically more. This one is lexicographically more, right? So that's why don't include 9 twice. So how to not include 9 twice? Instead of 9, insert the next or the like the lesser element which is not in your set right now. So up till val I have done, so include val minus 1. Is that clear now? Yes, no. What about like the guy who asked me this? Like everybody is saying it's clear, but what about him?
So if we don't want to insert one more 9, what are we doing basically?
We are inserting the element like a value which is one less than the last value that was inserted.
Can you explain with one example?
Yes. So let's take this example 648. So here I will add 1, here I'll add 2, here I'll add 3. So what is this? 7, not 7, 11. Here it's 6, here it is 6 plus 1, 7. So after sorting this, I'll get 11, 7, and 6. So in this, like I think it's pretty straightforward, but let's say val was initially, I can take it as infinity. So val is more than 11. So in that case, print 11. Now my val is 11. So now val is again more than 7. So just print 7 again. Like in this case, it's pretty simple. But is there any other case? Like let's say I had something like, let's say I had something like this. So in this, I'll add 1, 2, 3, 4, 5. Let's say I had something like 4, and then 5, 6, 7, 8. So this will become 3, 4, 7, 7, 7, 11, 12, and 9. So after I sort this, it will become in sort and non-decreasing order 11, not 11, 12, 11, 7, 7, 7, 9, 7, 7, 7, 4, 3. So initially my value is infinite. So value is infinite. Then value is more than 12. So 12, then value is 12 now. Let's say this is my value 12. So 12 is more than 11. So 11 is the best choice. Value is 11 now. So now 9, last was 11. So 9 is okay. Don't decrease it. Like what do I mean? Like I'm including them like this only. That means I'm taking in them in this order, like starting from backwards. Then because then this is getting added in this I'm adding n minus 1, in this I'm getting added n minus 2. But if I take this before and then this afterwards, then in this instead of adding n minus 2, I'm adding n minus 3. So basically I have control whether I want to add 3 or whether I want to add 4 or whether I want to add 5 or whether I want to add n minus 3 all the way up till this point, right? So here I'm saying I'll take 9 only. Then after this I have 7. So value was 9 and I'm getting 7. So I'll add 7 only. Then value was 7 and I again got 7. Now I don't want to add 7 here. Why? Because in set this will have no contribution. So I'll take val minus 1, 6. I'll decrease it by 1. Then my value is 6 and I got 7. So I don't want to add this 7 again because my value is less than this 7. So I'll add 5, val minus 1. Now my value is 5. Then I got 4, value is more than this. So take 4, then take 3. So this is the best that is you can get. Is it clear now?
How are we decreasing val minus 1 like this? Like, is it mentioned there somewhere?
Where like it's mentioned that you have to get lexicographically maximum, and once you take any element, all the elements after it, their indices will decrease by 1. So technically val minus 1 is nothing but you have taken one element before it, before selecting this. Val minus 2 is like instead of this 7, I introduced this 5, right? So that means for this 7, from where did this 7 came? This 7 came from here, and this was this element, right? So before this, I would have selected two elements, and because of that, this 5 would have became 3. So 2 plus 3 became 5. Is it clear? Yes, no?
You're changing index 5 to index 3,
Yes.
but
Is it clear to everyone else? Like, what about others? Okay. So let's do one thing. You can raise a query and ping me in it, and then like I'll explain it this thing over call there. Okay. If you're having like hard time understanding this. Yes, no. Is anyone still like other than you, is anyone still confused regarding this? No, right? Okay. So let me show you the implementation. So this is the implementation. In this, I have first taken n as input, then I have taken the array a as input. Then for each index I, I'm adding I plus 1 just because this is what is asked in question. Like this is what is told in question. Then I'm sorting this array A in reverse order, and initially I'm taking value as like very big. Let's say 2 into 10 to the power 9. Then I'm iterating through my array A in this order, that is decreasing order. And then I'm checking if the current value is more than value. This value is nothing but the last value that was inserted in set. So if this is more, I'm doing val minus 1. Why? Because up till val, I have already included values in my set. So I'm doing val minus 1 and my value is now decreased by 1. Because this is now inserted in set, right? So that's why this is the updated value. Otherwise, I'm printing E because E is less than val. And I'm updating my val. Val is the last inserted value in set. Finally, after printing this, I can print a next line. Is it clear? What about others? Okay, so let's go to the next problem. So in this problem, we are given that for a binary pattern P and a binary string Q, both of length M, Q is called P good if for every I between 1 and M, there exist indices L and R such that I is between L and Pi is mode of the string QL to QR. So first of all, what is this mode? This mode is nothing but character C is a mode of string T of length M if the number of occurrences of C in T is at least CL of M by 2. So there are these examples. But now what we have to do for a pattern P, let f of P be the minimum possible number of ones in P good binary string. So P good is nothing but this string, like this thing. So P good binary string of the same length of the pattern, and what we have to do, we are given a string S of size n, and we have to find for every substring of S, we need to find this thing. Like what is f of, for that substring, what is the value of this thing? So first of all, let me explain what is asked in the problem statement. Like we are given a string S. Give me a second. I don't know why this is not. Okay. So we are given a string S, and for every substring, what we have to do, let's say this is the substring from I to J. So for this thing, we have to find f of this thing, ij. And this is nothing but minimum possible number of ones in p good binary string. Minimum possible number of ones in a p good string, right? P good binary string. And we have to do this for every I, from 1 to n, and for every j from I to n. So basically for every substring of S, we have to find this thing, minimum possible number of ones in a p good binary string. So now what is a p good binary string? A p good binary string is basically for every I between 1 and n, there exists uh, L less than equals to I less than equals to R, such that I think this is a symbol for such that for every I there exists L2R such that like the count of pi, this thing, like count of pi in L2R is more than or equals to R minus L plus 1 by 2. Like basically this thing is the CL, right? So I've done plus 1, so that's why I don't have to write CL. So this is what we have to do. P good substring is this thing. P good string is this thing. That for every I from 1 to n, there exists L2R such that the count of pi, this character in L2R is like in L2R in string this thing. In string what? Which string? In string Sij. I'm looking for Sij right now, right? I will be between 1 to like m, and m is nothing but j minus I plus 1. So we have to do this thing, and out of all of these p good strings, we have to find first of all that good string which has minimum possible number of ones, and this we have to do for all substrings. Now this problem just seems difficult, like just seems complicated, but this problem turns out to be very simple. Why? Because looking at the problem constraints, it's given that n is between 1 and 100, and over all test cases n squared doesn't exceed 10 to the power 4. So what we can do if n squared doesn't exceed 10 to the power 4, this means that over all test cases, we can have an n cube approach. So we can iterate through every substring, every possible substring. And now, first of all, if I give you a string, can anyone tell me how will you calculate answer for this? If I give you this thing, how will you calculate answer for this? Anyone?
We can just put a 1 at the third place and rest zeros. That would satisfy the zero
Yes,
mode
yes, yes.
for the
This is
zero.
correct. But how did you come up with this?
I so I most of the time I took in this question. So essentially, for all the ones, we just want to ensure those are covered, and we have to put as minimum as possible so that they are covering each other. I mean,
Okay, okay. But
something
let's say
like that.
yes. Like you are correct. But let's say there was a 1 here too. Then what would have
Hmm.
been here?
Yeah. So what I thought of was, so I had multiple approaches. One thing was just break the thing into streaks of ones. So the
Yes,
last one will be one streak, and the other guy is the other streak. So for every streak, we just have to construct some the whatever that P good part. Just take care of that only. So I did many cases. It turned out to be streak length by two
yes,
floor, and the like just one exception corner case being if streak length is one, then you return one.
yes. So yes, that is also right. And the other thing is, what you can do.
No, so it did not pass.
Okay, okay. Because like you would have missed some corner case scenario. Basically, what you can do, see, if you have any kinds of ones. So what you can do for zeros, you just have zero. Oh, if you encounter one, you can keep a one and then move to this place, irrespective of these. Why?
Exactly.
Because this can be covered. You can keep a one here, and these all are covered, right?
Yeah,
They,
that also 1001
yes,
either way.
yes. For this one, you'll have another one. Then you skip these two. Just skip. Doesn't matter. It's a zero or it's a one. For this, you'll have one because it's a one. Skip these two. For this, you'll have a one. And let's say then you'll skip these two. It's a zero. So zero. It's a zero. So zero. So basically, there are four ones. So what you can do each time you encounter a one, increase your answer. Like you need a one here, and you can skip the next two positions.
Quick question.
Yes.
Uh, the the one from uh, the one that is third from the last.
Yes.
How are we extend like how are we guaranteeing there is a L2 are existing that so that mod like that's the mode. Uh,
Like how are we like? This is the string p, right?
no, when you are saying skipping, that means you are
Yes.
putting zero there, right?
Yes. Here I'll have zero.
So then,
But eventually, like this, this is the like when I'm saying there's a one for this, eventually there's a one not for exactly the under this, but for this.
yeah, I think now it's fine. The one
Yes.
that you have written now.
Like if I have one here, like uh, it won't. It will be like this. If you have a one here, then it will be like this. Like you if you have if you encounter a one, I'm skipping the next two places because I'm not keeping one beneath this, but beneath the next position. So it will take care of this one also, and this one also.
Sorry, I did not understand your construction. Can you take a clean
Yes,
slate and yeah,
yes. So let's take this example only, right?
yeah, works.
So they need to say for zero, it's a zero. For zero, it's a zero. Now for one, you I need a one, right? First of all, if there is a
Yes.
one, I need a one. Okay. So by the way, why do I need a one?
If you don't put a one here,
Yes.
then for the next guy, you have to anyway put a one in the next place for sure. If you are putting a zero here, so
Why?
better to keep a,
Like
or else you will never be okay. Okay, you cannot guarantee that.
no, no. You have to like you are right, but like you are right. If you keep a zero here, you have to keep a one here. So what like when I'm saying that I'll have a one here, what I'm doing, like I'm assuming that I'll keep one here, zero here, and zero here. So when you encounter, irrespective of what is in these two places, this will be what I'll do
I
if I
have two
encounter it.
questions.
Yes,
Sorry to interrupt.
yes, yes,
So
yes,
the argument that you gave is
yes,
as per your construction, right?
yes, yes,
So
yes.
as per your construction, you are saying a greedy argument that you have to always keep a one there, right? Now I have two questions. First of all, we don't know your construction is optimal or not. So because it's not optimal, how can you say as a guaranteed thing
No,
that
no,
okay, we have to keep a one?
like,
I
like,
I, I get it. Like
yes,
yeah.
yes, yes. This is like for, like, if, like, for this kind of approach, I can just brute force. I'm just counting how many places do I require, and
Mm-hmm.
when it increases, actually this problem is DP. So yes, in that cases we cannot like actually, but since this is simply like I'm just brute forcing,
Mm-hmm.
like what I'm
Okay.
doing, I'll iterate through every, so like every substring, and in case I find that okay, that there's a substring for which there's a one, then I'll simply skip the next two and increase my answer by one. So this way it simply works. Like
Skip to next two. Okay. Yeah,
skip,
yeah. This is actually this was my construction, but I wasn't sure if I did not pass anyway.
like okay, let me show you the implementation.
Something wrong with my greedy construction. Some arguments were wrong.
Okay, like you can raise a period and look into it. Probably this should pass. So
Mm.
this is like taking n and s as input. Initially my answer is 0. Now this is basically iterating over each and every substring. Like from I to j, there's each and every substring, and then I'm iterating through this substring, and I'm seeing that if the current character is 0, I'll simply continue. Otherwise, my current character is 1. So I'm increasing my answer by 1, and I'm like skipping next two characters. Eventually, see, after every iteration, my k gets to next character, right? But if I do k plus 1 here, I'm skipping one character. If I do k plus 2, I'm skipping two characters. So after this point, skip two characters. Is it clear?
It's clear.
Finally, we can print our answer. So
This.
it's just simply brute force.
So I did something like this, but
Yes, I think
answer.
you would have messed a little bit here in this part, like after iterating over each substring. So I'll look into it once. Like probably this part
Mm,
is something wrong.
okay,
So
fine.
yeah. Someone was saying something. Okay, okay. So that's it for today. And thanks.
Also, like why this is optimal?
Like this is just brute force. Like optimal. If you look at the second part, like the hard version for this, then you'll have to come up with like this thing. Like you cannot do there. So then you have to apply a complete dynamic programming solution.
I get it, but no, like DP, like let's forget about the DP
Yes,
approach.
yes. Okay, okay.
It's
This why,
it's
like you can just like write like you, if you need a one here, if you need a one here,
mm,
then you don't,
mm,
like irrespective of what these two are, they can be one or zero. You need a one here. Like there's a one.
correct.
So you need a one here. Then just forget about these two places. Then look at this. So this is
Okay.
just observation. Like this is just plain and simple observation from going through the problem statement. See, there's a one here, you need a one. So eventually you need a one around this. But then you don't have to look at these two places. And that's the maximum that you can skip. You cannot skip the further, right?
Yeah,
Like,
I got it.
yes. So that was the reasoning behind this.
So once you see a one, only you are jumping.
Yes,
Okay.
yes, yes, yes.
And there's anyway, we'll look into it. If I get any doubts, I will ping you.
No, yes, just raise a query and like tag me in it, okay?
What's
It'll
your name? Sorry.
Ankit. And by the way, like anyway, if you don't have any doubt in this solution, then also like raise a query and tag me it. I'll look at your solution. Probably that, like
Uh,
you are getting confused because of that only. Like you are trying to mix this thing with your, and I think like your solution would be correct also. Like you told me that thing, you did something like this only, right? But
so I also did lots of observations, and then finally I came up with a generalized thing. Maybe we can take it to the doubt. Let's not discuss it here.
yes, 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 you just raise a query and like I'll have a look at it, and then we'll share it over call only. Like, we can have a
Okay.
meeting.
Okay.
Okay. Okay. So bye bye.